All right, everybody, welcome. So this will be finding trig ratios with radicals. So this lesson won't be too bad, but we need to focus for like a good 5-6 minutes to understand the basics. So before we get into the actual lesson, let's actually just go over something very short and sweet. So here, let me zoom in a little bit. Okay, what I'd like you to do is please take a second and copy this down, right? And if you want to use colors, that would be great. Let me move this out of the way. Okay, so here, let's imagine we have some sort of triangle, right? And is the light? No. Okay, that's better. Let's say we have some sort of triangle, right? We have this triangle ABC. Now, if I were to ask you, which length of this triangle represents the opposite of theta? Okay, so take a second and try and figure that out. Here, what would be the opposite of this theta? If we look at theta over here, the opposite of the theta would be the length BC, or the side of the triangle called B to C. Okay, it would be this side over here. Okay, what if we wanted to find the adjacent of theta? Notice the adjacent is next to. So this would be the adjacent to theta, and we're going to call this, this is BA. Okay? And what's the next question? It's saying, what is the hypotenuse of theta? The hypotenuse is always opposite the right angle. So wherever the right angle is, if you look opposite of it, this C to A is the hypotenuse of theta. Okay? Let's look at same idea, but now imagine instead of the theta being here at angle A, let's put the theta here at angle C. Notice what would be opposite of the theta now? Which side of the triangle? Take a second and pause the video. Right? What would opposite of the theta be? This is opposite of the theta. It would be B to A. What would adjacent to the theta be? Now this might confuse you just a little bit because you're saying, oh, Mr. Opposite is next to, it could be this side or this side. But remember, this side has to be the hypotenuse because the hypotenuse is always opposite of the right angle. So what's the hypotenuse of theta? It's C to A, right? It's this side here. So then what will be the adjacent? It'll be not the hypotenuse, right? So here, it'll be C to B. Okay? Just so you get a feel for that. Now, something we need to go over very quickly, that let's say if we have this representation of a right triangle, right? And my bad, let me make the right angle over here. Let's just remember this SOHCAHTOA, right? Because this will be very important. Remember, sine of theta, what does this SO represent? Is opposite over hypotenuse. Okay? What about the ka over here? What does cosine represent? It's adjacent over hypotenuse. And here, what does the toa represent? This is opposite over adjacent. Okay. Now here, because we're talking about the angle A or theta over here, what is sine of theta? Notice if this is theta, it is opposite over the hypotenuse. So it's just 4 over 5. But what if we said what's cosine of theta? Cosine of theta is the adjacent over the hypotenuse. So it's 3 over 5. And what would the tangent be? It would be opposite over adjacent. So it's just 4 over 3. Okay? Now, the same thing were to happen if I were to say, instead of saying sine of theta, if I were to say, let me just fix this up a little bit. If I were to say, let me move, my bad. Let me move this, okay. If we were to say sine of A, It's the same idea as saying sine of theta, because here when you say sine of A, you're implying that your theta is at the position of A, or where that angle A is. So here, what is sine of A? We already did it. It's just 4 over 5, because what's opposite of the A? It's 4. What's the hypotenuse is 5. This is what? 3 over 5, 4 over 3. Okay? When we say sine of a letter, a big letter, we're putting that theta symbol right there next to it. So let's try and take a look at the next question. Imagine if it said, hey, what is sine of B? Notice that now we need to change the position of the theta and just put the theta over here. And now the question is, what is sine of B? Now what I want you to do is pause the video and take your time. Notice that sine is what? Opposite over hypotenuse. So notice, what is opposite of the B? It's this C to A. It's this 3. So notice that it's 3 over, and what's the hypotenuse? 5. What's the cosine of B? Notice you have to have adjacent over hypotenuse. So what's adjacent to this angle B? It's this 4. And what's the hypotenuse of the theta? It's right here. It's this 5. So it's 4 over 5. And what's tangent? It's going to be opposite over adjacent. So what's opposite of this B? It's 3 over 4. So notice it kind of like switched around, right? Like this went here, this went here, and these two flipped. Okay? Let's see what happens when we do it for C. Okay, so what is sine of C? Notice, what do we need to do? We need to put the theta over here. So now here, what is sine of theta? It is, what is my actually, yeah. What is the opposite? Wait a minute. Sine of 90. Oh yeah, that does make sense. Okay, so it's here. I know it's a little weird and confusing, but what's the opposite of the theta? It's 5. The opposite is 5, but the hypotenuse is also 5. So notice that it's 5 over 5, because this represents the opposite and the... Actually, you know what? Let's not do this, because then we have to ask ourselves what's the opposite and adjacent over here, and that's a little bit weird. So my bad. Ignore this. Let's just do A and B where was fine. Okay. Great. So now let's actually go back to this question over here. Imagine if we had this over here, and we wanted to find sine of A. Notice what I want you to do is take your time and draw this diagram. It's saying, what is sine of A? Here, well, if this is A, let's put our theta at A. Okay. Now, what is sine of A? So here we need to do opposite over hypotenuse. Now notice that this becomes, what's the opposite? It's 6. And what's the hypotenuse? It's square root of A5. Now this is where in math we become a little bit OCD. A fraction is not considered, it's not considered simplified if there is a radical in the denominator. So notice here that what is the sine of A? It's 6 over square root of 85, which is correct. But you're not allowed to have a radical in the denominator. So what would you do how would you get rid of this radical in the denominator? What's the trick? Okay. If you know, try and do it yourself. If you don't know, the idea is you want to multiply this whole entire 6 over 85 times 1. But how are you going to represent this 1? Notice that isn't 1 equal to, just be patient with me. Isn't 1 equal to, let's say 7 over 7, right? 1 is equal to 100 over 100, right? 1 is equal to alpha over alpha. So if you have the same number and the top and the bottom for the numerator and denominator, it's equal to 1. So is it 1 also equal to square root of 85 over square root of 85? Like this has to be true. So the idea is you're going to multiply this 6 over square root of 85. You're going to multiply it by square root of 85 over square root of 85. And notice that when you're doing this, what is 7 times 1? It's 7. Like if you multiply a number by 1, the value stays the same. So notice that you're multiplying this value. What is this value? It's 1. What is 1 times anything? It's the same value. You're just going to change the way it looks. So how will it look like? Notice what's on the top. What is 6 times square root of 85? It's 6 square root 85. And what's on the bottom? It is square root of 85 times square root of 85. Now here I'm being a little extra because what is, let's say, and I'll just have this here, like let's say if I have square root of 9 times, let's say like square root of 3 times square root of 3. Well, that's equal to the square root of 9, or it's just 3. The idea is it just cancels the radical. And that's what's happening here. What's the square root of 85 times the square root of 85? It's just going to be 6 over square root of 85, and it cancels this radical, and it's just 85 is on the bottom. And notice that we solved that problem we had where a fraction, now this fraction is considered simplified because here you don't have a radical in the denominator. And that's it. So here what we could say is that the sine of A is equal to 6 square root of 85 over 85. Okay? This and this are the same value. It's just that this one doesn't have a radical in the denominator. All right? Let's try another one. Here, imagine if you got a question like this where it said, what's tangent of A? Notice that if this is your theta over here, what is tangent of A? Here it's just opposite over adjacent. And now here, what's the opposite of your A? It's 6. What's the adjacent to the A? It's 1. So you just have 6 over 1, or you have 6. And then your life is very easy if you get something like this. But here, it's really not even too bad if you get something like this. You just have to rationalize the denominator. Okay? I hope this helped. What I want you to do is, there's a Delta Math which has you it makes you practice some of these questions with sine, and there's one with cosine and tangent. Okay? If you have any questions, we can go over it in class together in the Google Hangouts. Okay? I'll see you.